Hi there. So in this particular section, we're going to take the idea of slope and expand upon it, and with graphing as well as applications. We'll start first of all by talking about the slope-intercept form of a line, which is given by this equation right here, y equals mx plus b. You'll need to know that formula. M is just your, remember, your symbol for slope, and b is for your y-intercept. So m is your slope, and that b there is your y-intercept. Okay. And whenever an equation is written in this form, it allows you to easily pluck off what the slope and the y-intercept are for that particular equation. And if an equation is not already solved for y, it can be solved for y so that you can identify what the slope and y-intercept are. But after an equation is solved for y, the number in front of x is your slope, and the number that's being added or subtracted at the end is your y-intercept. So let's come on down below in example 1, and it wants us to find the slope and y-intercept for these linear equations. So let's do A and B here together, and let you pause the video and try example C and check about the solution key. All right, so in letter A here, it wants to identify again the slope and y-intercept. So my slope, this equation is already solved for y, so the slope is just the number in front of x, so my slope here is 2. And my y-intercept is the number that's being added or subtracted at the end. So my y-intercept is 4. This is going to be important for us here in a few moments whenever we start looking at applications of linear functions as well as graphing in slope-intercept form. Moving over to letter B, don't let the fractions scare you off. Again, this equation is already solved for y. So my slope, and remember, if it's already solved for y, the number in front of x is your slope. So my slope this time is 2/3. And my y-intercept, a negative 1/3. Final answer. Okay. All right, let's move on down to example 2. And example 2 is asking us to find the exact same thing, the slope and y-intercept, but you'll notice in both of these equations that they're not already solved for y. I'm going to do the example B. I'm going to do this one with you because it's just a little bit more involved than example A, and let you go back and do example A solo. So moving over here and looking at letter B, the first thing I'd want to do in order to get closer and closer to getting this y all by itself is let's take this -2 and distribute it through to that parenthesis. So I'm just going to bring down my y minus 8, -2 times x, -2 times 6. And then the last step here is I need to get this y all by itself, so I need to bring -8 to the opposite side. So remember, anytime you cross the equals mark, always do the opposite. So I'll add 8 to both sides. Cancels out here on the left-hand side, and you're left with y equals -2x, -12 plus 8. That's going to give us what, a -4. So now we can identify that my slope is -2, and my y-intercept, -4. Final answer. Okay. All right, so if you remember in the previous section, we graphed using x and y intercepts. In this particular section, we're going to look at graphing using graphing using your slope and your y-intercept. So these are the steps here. I'm just going to come down here and show you those steps. But essentially, if you think about it in slope-intercept form, y equals mx plus b, the first thing I'm going to have you identify is your slope and your y-intercept. But notice how your b is your y-intercept, and I've got a little acronym back here that tells you that's where you begin. So you're always going to begin on the y-axis at your y-intercept, and then your slope is going to tell you how to move. So up and to the right are positive movements. Okay, so I've got that up here in parentheses, that positive numbers indicate that you're going up or to the right. Negative numbers indicate that you're going to go down or to the left. Okay, so in example 3, I'm going to do letter A here with you, and then I'm going to flip it over and do C with you, and then let you try the other two on your own. Okay, so the first thing that you do with these problems, it says it wants you to graph using using a slope-intercept form. So the first thing, and it does have here to graph at least 3 points, and I think we should be able to do that here with these problems. So the first thing I'm going to do is I'm going to identify my slope and my y-intercept. So again, this equation is already solved for y, so my slope, the number in front of x, y-intercept, it's going to be that -2. So remember, you begin on the y-axis at that y-intercept, so I'm going to begin on the y-axis over here at -2. There's my -2. Remember, this is your y-axis. Here's your x-axis. And then from that -2, remember, slope is also known as rise over run. Both of these are positive, so the rise go up 1, 2, 3 units. And then my run is positive, so I'm going to run 5 units to the right. 1, 2, 3, 4, 5, and put a dot. And then I'm going to repeat that. I'm going to go up 1, 2, 3, and then over 1, 2, 3, 4, 5. Perfect. I'm able to put 3 points on there. Okay. And then I'll do my best to connect those 3 points there with a straight line. Not too bad. Okay. Give you a minute. Try B. I'm going to go ahead and flip it on over and look at letter C here with us. You'll notice that likewise in letter C that my equation is not already solved for y. So the first thing I want to do is get it solved for y. So I'm going to first take this negative 2 and distribute it through. So I have negative 2x minus 8. I bring down the y minus 8. And then next move, I'm going to take that 8 to the other side because I want to get y all by itself. So the 8's cancel out, actually on both sides, and I'm left with y equals negative 2x. And I can put a plus 0 out there if you like. Now, so let's identify my slope and y-intercept. Slope, negative 2. You know with slope, we're going to need a rise and a run. If it's not a fraction, make it a fraction. Put it over 1. You can always do that. That's always legal. Y-intercept, 0, 0. So I begin on the y-axis at my y-intercept. So I'm going to begin at 0, 0. And then from that point, so remember this is rise over run. So my rise this time is negative. So instead of going up, I'm going to go 2 units down. But my run is positive, so 1 to the right. Down 2, 1 to the right. Now I said in the directions you only have to do 3 points, but I'm going to go down. I'm going to go down a couple more times. Down 2, 1 to the right. Down 2, 1 to the right. And then I will connect those points. And that is the graph for that equation. And of course, it should have passed through those points. My pen just got a little off there. I mentioned this in the previous video, but I'll say it one more time. You notice here that this slope is negative. As we're reading this graph from left to right, this graph is going down. It's decreasing. I'm going to go back to my previous page. In letter A here, my slope was positive. As I read this graph from left to right, this graph is going up. It's increasing. Okay, so if you've got a positive slope, you need to be increasing from left to right. If you've got a negative slope, like you had here in letter C, you need to be decreasing, going down from left to right. Okay. All right, so now let's move on from here and let's look at some linear, writing linear equations and some applications. Okay. So a lot of times the information that we need is going to be directly stated for us in the problem, and we'll just be able to, by the context of the problem, be able to pull out what we need. Okay, so let's look at example 4 here together. It says that a paintball field charges $25 to rent a paint gun for the day and $5 for each small bag of paintballs. So we could write an equation in slope-intercept form to find the total cost of playing depending upon the number of paintballs purchased in a day. So part A wants us to identify the slope, or in other words, the amount of increase for our cost for this particular situation. So each time we buy a small bag of paintballs, we are increasing our cost, and so the cost of those paintball bags are $5. Okay, so that would be our slope. Your y-intercept, remember, that's always your starting point. Okay, so what's the base cost to get to play? You would have to that they charge $25 to rent the gun, so that would be your base charge, would be that $25. And then part C says, well, let's use our answers now to write an equation in slope-intercept form to give us the total cost. So remember, we're going to put it in y equals mx plus b. M is how we're changing. We're changing by the number of paintball bags that we buy. And then B is our initial cost, which is $25 for the gun itself. Sometimes using intuitive letters is helpful. So in place of Y, let's say I used C. C would represent the cost. 5, and let's say P represents the number of paintball bags, plus 25. So I'll put over here that C represents the cost, and P equals the number of, let's say, I'm going to do paint bags that you buy. Okay, so maybe you buy one bag, it's only cost you $30 to play. You buy, part D says, let's use this equation now to find the cost if you were to purchase 3 bags of paintballs. Okay, so if we're going to purchase 3 bags, I'm going to be plugging 3 in for my C or my P. And this is where the intuitive letters come into play. It is perfectly fine if you left it right here in this form, the y equals 5x plus 25. Just know for yourself that the y is representing the cost and x represents the number of paintball bags. All right, so in our case here, we're buying 3 paintball bags, so I'm going to be plugging 3 in for my x or my p. So 5 times 3 plus 25, which would be what? 15 plus 25, which will give us a cost of $40. Okay. Um, and then just the note down below is that, we can always use X and Y, but sometimes if you convert it to other letters, that it can be helpful. And that's what you're going to see play opposite here in example 5, that if it's given to you in other letters and it's asking you for what the slope and y-intercept are, you can always come underneath that and write it in y equals mx plus b format. So let's see how that plays out. In example 5, it says the total cost of labor for a plumbing repair depends on the time spent on the job, and can be calculated using this equation here, C equals 45H plus 50, where C represents the cost in dollars for your repair, and H is the hours of labor. So part A wants us to find and interpret the y-intercept, and part B wants us to find and interpret our slope, okay? So I'm going to come on down below here, and again, if using these intuitive letters here is challenging for you, it's in slope-intercept form. Just come underneath here, y equals mx plus b. And so then that tells me, okay, my y-intercept then has to be 50. So my y-intercept here is 50. It's telling me then, it's also really emphasizing here that x represents the number of hours. So this is hours, and y represents our cost. And so essentially what it's telling you here is that the base cost for this plumber is $50, okay? Because he's not done any work at this point, so basically just to get him to your house, base cost would be $50. So the base cost of the plumber is $50. Now, part B wants us to find and interpret the slope for this particular situation, all right? So my slope, remember, that's after you've got it solved for y, that's the number in front of x. So my slope here is 45. I'm going to put it over a 1 there. Now, remember from our previous set of notes that slope is equal to the change in y over the change in x. I find if you will just take the time to do this little bit here of writing out just a small little word phrase, the sentence for interpreting this slope will fall right out. So on the y-axis, what are we measuring? With the y-axis, we're measuring the cost. And on the x-axis, we're measuring the number of hours. And then from here, like I said, the sentence will just fall right out. So that what this is saying is that for every for every additional hour, you can even just say for every hour, the plumber's cost increases or decreases? Hopefully you agree it increases because that 45 is positive. If the 45 was negative, we'd say decrease. The plumber's cost increases by $45. So I always start on the bottom, that for every, in this case hours, so for every hour on the job, the plumber's cost increases by $45. Final answer there. All right, let's flip it on over. In example 6, it wants you to identify your x and y intercepts and then just interpret its meaning. I think that one is very self-explanatory. We spent a lot of time in the last section identifying x and y intercepts, and the interpretation part, I think that's very going to be self-explanatory. If you struggle with it, though, you'll be able to see it from the solution key. So I'm going to let you try that one on your own. Let's come on down then and let's look at example 7. So down below here, again, remember, an equation of a line in slope-intercept form is y equals mx plus b. And to write an equation in slope-intercept form, you first have to know what your slope is, and you also have to know what your y-intercept is, okay? So looking at this graph here in example 7, it wants me to write the equation of this line. And believe it or not, we have enough information because remember, we want to write it in y equals mx plus b format, okay? I'm actually pull this over here. This is where we're headed. Y equals mx plus b. All right, so let's first find our slope. So m, remember, is rise over run. Remember from the last section, pick 2 points that you're not having to guess whatsoever what those ordered pairs are. I'm gonna choose again. I'm gonna choose the x and y intercepts. Excuse me. And I'm going to rise and run. So I'm going to rise until I get in line with that other point. So I'm rising 6 units. And then I'm going to run until I'm on top of that other point. So I ran 8 units. That can be reduced, divide them both by 2. So 3/4, there's my slope. Your y-intercept, you've got the graph sitting here in front of you. Remember, your y-intercept is where you're crossing the y-axis. I'm crossing the y-axis down there at -6. So I'm ready to write my equation then. In place of m, I put in my slope. In place of that y-intercept, I put in my y-intercept, which in this case, since it's a -6, I'm going to just change that plus to a -6. Final answer. Okay. Now, you will not always, sometimes that's just one example of giving you a graph and saying write the equation. By me giving you a graph, then you're able to pluck those items off and use the skills that we talked about in the last section. Sometimes though they are a little bit more involved, and if you're given, you might be given other pieces of information. So there's a 4-step process that you will utilize to find the equation depending on what you're given. So the first thing that you're always going to find is the slope. If you're given 2 points, you're going to plug those 2 points into the slope formula to find your slope. Then you're going to use that formula y equals mx plus b and substitute in everything that you know. And what's going to happen at that point is you're going to know your m, and you're going to take one of the ordered pairs and substitute it in for x and y, and you'll be solving for the b. Okay? And that's what the third step tells you to do, is solve for b. And then lastly, you'll write your equation in slope-intercept form. So of course, I'm going to go through down here example 8, and I'm going to take this one from top to bottom with you, and I'm going to write it in a 3-step process, okay? Step 1 is you always find the slope. This one wants us to find the equation of a line passing through these 2 points. So I'm given 2 points. The best way to find my slope then, use my slope formula. So x1, y1, first order pair, x2, y2, that's your second order pair. So to find my slope, let's plug in what we know. So y2, 12 minus y1 on the bottom, x2 minus x1. Up top, those two negatives turn into a positive, 30. On the bottom, those two negatives turn into a positive 10. 30 divided by 10 just gives us 3. So we've got our slope. Step 2 is you're always going to find b, that y-intercept. Underline that for us. Again, like I said above, you use the equation that you already know, y equals mx plus b. And now we plug in what we know. We know our slope we just found is 3. And here's what's going to happen is you're going to plug in a value for x and y, and you're going to be solving for b. We're solving for that b. That's what we don't know. You can choose either order pair that you want, but what you can't do is cherry pick. You can't say, oh, I want to use that x and that y. You pick a point and go with it. Personally, in this problem, I would go with the second order pair because they're all positive. Because a lot of times folks make mistakes whenever they're working with negatives. So, but it's entirely up to you. You can use the first order pair. You'll get the exact same answer as long as you place them correctly in for x and y. Again, like I said, you just can't cherry pick. You've got to pick an order pair and go with it. So if you choose this x, then you got to use that y. We choose this x, we got to use that y. We can't mix and match. So I'm going to choose to use the second order pair and plug that in for x and y. So in place of my y, I'm plugging in my 12, and in place of my x, I'm plugging in 7. Okay, so now from here, I'm just going to start cleaning up. I want to solve for b. So 3 times 7, we know 21. Last step to get that b all by itself, and we can take 21 to the other side, and you cross the equals mark. Always do the opposite, so subtract. Cancels out over here, just leaves me with b. 12 minus 21 should give you what, a -9? So you found your b. Last step is to write your equation, and this is your easiest part. So y equals mx plus b. And then this last step, all that happens is you substitute in for m and b. That's it. Okay, so final answer then would be y equals, in place of m, put in 3, and in place of that b, the -9. That is the equation of the line that passes through these 2 points right here. Y equals 3x minus 9. Okay. All right, so let's flip it on over. Um, I'm going to go ahead and do B here in the notes in the video, but if you'd like to try it first on your own, I encourage you to do so, and then you can play it if you need the help, okay? So again, I'm finding the equation of a line that passes through this point, and it has a slope of -4. It's the same 3-step process. So step 1 is to find your slope. But the nice thing about this problem is it was given to us. So here I know my m is -4. I don't have to do any work. The previous problem gave me 2 ordered pairs, so I had to find the slope. But this problem is telling me what my slope is. All right, step 2 is find your b. Well, it wasn't nice enough to tell me what my y-intercept was, so I'm going to have to do the work there. So y equals mx plus b. But this time we don't have any choices. We have an ordered pair here. This is your x and this is your y. So in place of y, plug in 3. In place of m, there's your -4. X is 2. -4 times 2 gives you what kind of 8? Will you agree with a -8? Lastly, get that b all by itself. So add 8 to both sides. So b equals 11. Final answer, write that equation. Remember, you're writing it in y equals mx plus b format, and you're only substituting in for your m and your b. So the final answer here, y equals -4x plus 11. Final answer. Okay. All right, let's wrap up here with example 9. In example 9, this is giving you the life expectancy for American women from 1930 to 2000. So this is their expectancy, of course, measured in years. In part A, it says you're given a scatter plot, so the points here have been graphed for us. They want us to, they have here, they say notice the trend line, and it's asking you if you're observing a positive or negative trend for female expectancy. And so if we're reading this graph from left to right, since we are increasing, we would be observing a positive trend. Okay. All right, we'll move on down to letter B then. B says find the equation of a trend line in slope-intercept form for these points here. So here's the 2 points that I chose, the 1941, so the very first point, and the 1980, that one. Okay. So I'm going to repeat that same 3-step process because it wants the equation. So it wants that y equals mx plus b format. So I'm going to repeat that same 3-step process that we just got finished doing. First step, let's find that slope. All right, so remember x1, y1, x2, y2. All right, so m equals 77.4 minus 65.2. On the bottom, 1980 minus 1940. Subtract on the bottom, we've got what, 40? Subtract up top, 12.2. Do that division, it comes out nicely, 0.305. Step 2, find that b, that y-intercept. So I'm going to go my y equals mx plus b. So in place of our m, I'm going to put in our 0.305 that we just found. Again, you can use either ordered pair. Maybe this time I'll use the first ordered pair. Both of these ordered pairs are both positive. Okay, so you could use either one. Again, just don't pick this x and that y. If you pick an ordered pair, you got to go with it for that, using that x and that y. So in this time, I'm going to do 65.2 in place of y, 1940 plus b. Multiply on the right hand side, that should give you 591.7. Subtract that 591 because I want to get b all by itself. Cancels out over here, and b equals a negative 526.5. Last step, your equation. y equals 0.305x minus 526.5. That would be my equation of my trend line there, passing through these two specific points. So that would be, it would be passing through this point and this point. So the equation of a line passing through those 2 points. Part C wants us to use this linear model that we've just created to estimate the life expectancy for a woman in the year 2025. Okay, so think about it. We're measuring years on which axis? Our x-axis or our y-axis? You're measuring it in your x-axis, so that's telling me I'm going to be putting 2025 in then for x. So in my equation, 0.305 times 2025, that's a 2. Let me fix that. Multiply and subtract. You should be able to put that in your calculator all at one time. I've got you rounded to the nearest tenth. Make sure that you can land at 91.1 years. So average life expectancy then in 2025 would be just a little over 91 years old. Part D wants us to find and interpret our slope. So our slope, remember I've already, and I go back to part B, here's my equation. The number, after you've got it solved for y, the number in front of x is your slope. So here's my slope, 0.305. Let's make it a fraction by putting it over 1, because remember slope is change in y over change in x. On the y-axis, we're measuring life expectancy. Oops. So this would be life expectancy. And on the x-axis, we're measuring years. So now we can write our equation that every year, we're talking about women here, so every year a female's life expectancy increases or decreases? Increases by 0.305 years. So I'll write that for us. Every year a female's life expectancy, I'm just going to abbreviate there, increases by 0.305 years. All right, that finishes up this section. That's a lot. Bye.